Hi everybody, welcome to another video in Pre-Calculus section 8.2 Polar Equations and Graphs. So recall from previous section from rectangular coordinates of x and y to polar coordinates of r and theta. So x and y in rectangular coordinate and r and theta in polar coordinates. And the formula is related xy to r theta given like this. And as mentioned before, if we use this formula to find theta, make sure that it is in the correct quadrant. So I just put a note here, check the quadrant. Next, an equation whose variables are polar coordinates is called a polar equation. The graph of polar equation consists of all the points whose polar coordinates satisfy the equation. Right. Because we have some example here. We have a point in rectangle coordinates, and then we have some point in polar coordinate. Of course, those points are not the same. I'm just going to put the graph here. Right. So let's look at some example. Identify and graph the graph of the following polar coordinates. So first, r equal to 4, meaning that theta is not there, right? So theta could be anything, or we say theta is arbitrarily chosen. So we can choose theta to be any values, but r is equal to 4, so 1, 2, 3, 4. So because of that, this will be in a circle, radius 4, center at 0, 0. So r equal to 4, so it's going to be 4. Angle can be anything, so that's why it's a circle. So we graph it, and we say this is a circle with radius equal to 4 and center at the origin or at the pole. Right? Straightforward. Next, theta equal to 3 pi over 4. This one r can be anything because it is not in the equation. So we can say r is arbitrary. Right. So how do we turn this into the equation that have x, y in it? By the way, if we want to write the equation in rectangle coordinate, we can do that too. So remember r, we can say r is square root of x squared plus y squared. Square both sides. So we have x squared plus y squared equal to 4. So equivalently, in rectangular coordinate, we can write this equation: x squared plus y squared equal to 4, which is equivalent, 4 squared, right? Or 16. So x squared plus y squared equal to 16 is equivalent to r equal to 4. Right. Now, if we want to graph in polar coordinates, hit mode, go to polar. Oh, sorry, I passed it. Function parametric polar sequence. We're going to go to polar. And enter. That's it. When we hit y equal down now, it will show in polar. So r equal to 4. If we want theta, this will be theta. But that's what we have. And then let's look at the graph. It is a circle. We said not quite circle because the x and the y-axis do not have the same scale. So if you want to have the same scale, hit zoom, number 5, zoom square. There, the circle. Right, next, this one, the calculator will not graph. You see, in order to graph it, we have to have theta, r equal to a function of theta only. So, however, notice that in this case we have 3 pi over 4. 3 pi over 4 is like 135 degrees. And this is going to be in this line, because r could be anything, right? So the angle here is 3 pi over 4, and r can be anything, so we have the whole line. So it is a line. Right. Is there a better way can we write this equation in terms of y and x? And of course, yes, in this case, why don't we take the tangent on both sides? Tangent of theta is y over x, right? Tangent is y over x. So y over x and tangent of 3 pi over 4. By the way, when we graph, make sure it is in the radian mode. Tangent of 3 pi over 4. This will be negative 1. Yep. So the equation turned into y equal to negative x. Because when we write y equal to negative x, we know that it is a line, the slope equal to negative 1, and the lines go through the origin. So that is the line go through the origin with the slope equal to negative 1. Right. So we convert from r and theta to x and y. And so we have the equation in rectangular form. Right. Next should be easy. R sine theta equal to 2, and obvious now. We've seen quite a few of them. R sine is equal to y equal to 2. And if we draw the line y equal to 2, it is a horizontal line. So this is horizontal line. At y equal to 2. Similarly, r cosine theta is going to be x. X equal to negative 3 is the vertical line when it goes to the point x equal to negative 3. So this is the vertical line. That go to negative 3. This one go to 2. Right, so simple enough. X equal to r cosine theta, y equal to r sine theta. R is equal to square root of x squared plus y squared, and tangent of theta is y over x. So pretty much I utilize all of those formulas. Right, now this one is a little more interesting. Identify the graph of the following polar equation, r equal to 5 for sine theta. So let's graph 4 sine theta, 4 sine of theta. Once again, this one, make sure in the radian mode. Graph. So I have a circle. Zoom in. I have to zoom out again. Right. So it is a circle, right? Radius at 0 and 2. Right. So we know that it is going to be a circle. Radius at 0 and 2. So the radius here, center here, and we're going to have so circle like that. So how do we write the equation in rectangular form? So r equal to 4 sine theta. Right, let's quickly go over what formula we can use. R cosine theta x, r sine theta is y, r square x square plus y square, and tangent of theta is y over x. So we can use only those. Right, now we have sine. It would be nice if we have r there, right? So why don't we multiply by r on both sides? So once we multiply r on both sides, here we have r sine theta give us y, right? And r square give us x square plus y square. So we have the equation x square plus y square equal to 4y. That's good. How do we get into the equation of a circle? Well, that involving completing square. So we subtract 4y on both sides. Now let's look at the equation. By the way, this is the equation in rectangular form. X squared plus y squared equal to 4y. I can subtract 4y on both sides. And we have x squared plus y squared minus 4y equal to 0. Now, if we want to turn the equation into the standard form of the circle, the standard equation of circle in standard form, we have something with x squared, something with y squared. So in particular, this is what we do. We can add something here to make it a perfect square, and then we can add something on the other side. Right, so to get to a complete square, meaning that we're going to turn this into a square, what we do is we're going to take this middle number, half of the middle number. If the coefficient is 1, we take half of that. And then we square it. Negative 2 squared is 4. Add to both sides. And then we just have that equation. Right. Once again, to complete the square, we take half of the middle numbers, put in a square, and then we take that number square, add to both sides. That's what we have. Now we write the equation. We have x squared plus y minus 2 square equal to 2 square. So this is the equation in standard form. From here we can say the center will be x minus 0, so it will be 0 for x, 2 for y, and then the radius will be 2. So in general, if A is a positive real numbers, then we have the following circles pass through the pole. Is that? Notice that when we have sine, the circle will be a kind of the vertical circle. This will be a line on the y-axis. If it's positive, it is above. If it's negative, it is below. If we have cosine, it's going to be left and right. Positive on the right, negative on the left. Because we summarize in this case. Once again, if we have r equal to 2 times a number, if it's positive, and if it is sine, it will be above the pole. If it's negative in sine, it will be below. Negative cosine will be on the left, positive cosine on the right. Right, next, the equation in rectangle in polar form, we have the symmetry. If we have the following, if we have the equation, if we replace theta by negative theta, we obtain the same equation. For example, cosine of negative theta, because cosine is an even function, cosine of negative is cosine of a positive theta. So in that case, the graph will have symmetry with respect to the polar axis. So if we replace theta by negative theta, and we get the same equation, that is symmetric with respect to the polar axis. Now with respect to the line r equal to pi over 2, if we replace theta by pi minus theta, and we have the same equation, so that will be the equation symmetric with respect to the line theta equal to pi over 2. And symmetric to the pole, we'll replace r by negative r, or theta by theta plus pi, get to the same pole. By the way, we can of course graph this, and we can see the symmetry nicely. Right, mode, it is in polar mode, and it is in radian, so we need to check those two. Right, 3 cosine theta. Right, yeah, because that's a circle on the right. It is symmetric on the line y equal to x. Yeah, symmetric to the line y equal to x, upper half and lower half. Now let's graph this one. 2 equal to 1 minus sine theta. So what we have here is called a carioid. I should zoom out. Yeah. So we have a carioid or a heart. And of course this is symmetric by the line y equal to by the line the y-axis, or theta or pi over 2. We cannot really graph this because of r square. Right, but we will have those examples. Right, now some common graph. Of course, I'm not gonna ask you to memorize all of the equation and all of the name of the graph, but those are the graph that we have. So those are the names. Of course, if we want to graph anything like the one we just did, just put in the graph, like the carioid. Now, if we want to graph the limison with an inner loop, so we're going to choose something a greater than b. So for example, r equal to 4, a have to be greater than b, so b is 3 cosine theta. And again, if we have cosine, we can put negative or positive theta, still the same thing, because cosine is even function. So this graph will be symmetric to the line, the polar axis. As we see, this is symmetric to the polar axis. So this is the limison without a loop. If we want a loop, we have to choose a less than b. Now we have the loop, too small to see. So how about 4 and 6? So we have the graph of the limison with a loop. So it depends on where we choose the numbers a or b, we have a loop or not. But if it is cosine, it will be symmetric with the line y equal to, symmetric with the polar axis, because if it is just cosine, if we have sine, cosine, different story. But if we have just cosine like this, it's surely we can put negative or positive in, still the same thing. Therefore, it is symmetric on the polar axis. Right. Next, we have roses or rose petal. Now, we can have cosine or sine. It doesn't matter though. Of course, if it is cosine, it will touch the x-axis, will go to the x-axis. This one will go to the y-axis like this, so it's going to be sine. Right. And also, if n is even, we have 2 times the number of petals as n. And if n is odd, only 1 time. So if we want to draw a 4 petal we only need 2. For example, cosine of 2 theta. We're going to have 4 better, too small. Let's put 5 in it, so make it bigger. There, you see. Again, zoom number 5, so we have the same coordinate. So 4 parallel, choose n equal to 2. If we want 7 parallel, if an odd number, we just use the same number. So that 7 parallel. And we say it's not look really like a rose petal, right? So that because the point here. So we hit Windows, we go from 0 to 2 pi, which is good. But the step, if we want to go very small, it will graph very slow, but it will be very smooth on the curve. Right, because this one has the cosine. This one has the cosine, so it will go through the x-axis. And then the lemon cage, we have that. Right, of course, we talk about the graph of this one, right? This is the cardioid. So if we want to graph something like this, of course, we can test the symmetry. By the way, is that what form of symmetry is this? Right, let's graph first. 2 and 1 minus sine of theta. It's too small. Right, remember, we choose the increment too small, so that's why graph is extremely slow, but the graph will be extremely smooth. Right, let's change this to 0.5 graph. That would be better. Right, let's zoom out, zoom in, so this is the graph of a cardioid. Okay, if we want the point, hit second table, and we have the point in polar coordinates. This one in polar coordinate. Right, but if we want to test the symmetry, of course the graph itself is easy. Just look at the calculator, we can have the graph. But if we want to test the symmetry, so first of all, let's do that. Is it symmetry or symmetric on the polar axis? To do that, I will replace theta with negative theta. And sine of negative, sine is odd, sine of negative is negative sine. So we have 1 minus the negative sine. And this is not the same as the original equation. So nope, this one not symmetric on the polar axis. Right, next, how about symmetric on the pi over 2 axis? To do that, I will replace theta with the supplement. And then what is sine of pi minus theta? That will be equal to sine of theta because sine is supplement. Because if we don't want to memorize it, we can always derive manually. So sine cosine minus cosine sine. Sine of pi is equal to 0, and cosine pi is negative 1. Negative 1 times negative is positive. So that gives us equal to sine theta. So when we replace that, we have r equal to 2, 1 minus sine of theta. This is exactly the same as the original equation. So yes, so this is symmetric on the axis theta equal to pi over 2. Next, is this symmetric on the pole? To do that, all we do is just replace r by negative r. We know it's not going to work, right? If we replace r by negative r, there's no way this equation are the same. So if they are not the same, they're not symmetric on the pole. So in this case, it is only symmetric on the line theta pi over 2. So we will graph half of it, and the other half will be symmetric to it. So to graph this, just like when we graph anything, we're just going to choose theta and y will be follow. So for example, we just plot the points at theta equal to 0. When theta equal to 0, r equal to 2, 1 minus sine 0. Sine of 0 is 0. So this is 2. So for theta equal to 2, we have the point r theta is 2 and 0. So 2 and 0. Now choose another point, something that we can evaluate. Pi over 6. R equal to 2, 1 minus sine of pi over 6. 2 sine of pi over 6 is 1/2. Right? And that is 2 times 1/2 is 1. So the point is on theta, r equal to 1 and theta equal to pi over 6. So this is pi over 6, r equal to 1. Sorry, this point. And then we can choose pi over 4, pi over 2, something that we can find about. Of course, the calculator will do a lot better. The calculator do not know what the graph is. They just plot a bunch of points, and when we see all the points, we know the graph. Now if we choose pi over 2, r equal to 2, 1 minus sine of pi over 2. Sine pi over 2 is 1. 1 minus 1 is 0. So this is 0. So we have the point on theta r equal to 0 and pi over 2. Of course, if pi r equal to 0, we're talking about the point at the origin. So we have this point. If we choose more point, then we have the whole graph. But of course, put everything together, we have the graph. And when r equal to pi, or 3 pi over 2, sorry, r is equal to 2, 1 minus sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. So that gives us 4. So when we have 3 pi over 4, this which go to negative, go to 4, 1, 2, 3, 4. Yeah, so and then of course we have the other symmetry on the other side. Of course, we just plot a bunch of points and connect them to have the graph. But that's what we have. Of course, we can check the symmetry. But of course, the calculator can help us. To graph these polar coordinates. So in this section, what we learn is that we're just gonna use those equations to link between polar coordinates and rectangular coordinates, and we can graph. And we did show how to graph on the calculator. Right. Of course, then we have the names of different, some common polar equation. But like I said, I'm not going to ask you to memorize any of this, the name of it. But of course, you just need to see it, so later on, if you see this again in calculus 2, it will not be a surprise. Alright, so I'm going to stop the video here. Thank you for watching. See you in another video in calculus.